Okay, so I'm going to give you a sort of an introduction to electrochemistry. And so one of the things that we need to understand to do with that is about electrochemical cells. So I've set up something here that's called a half cell. I've got some copper sulfate solution in the bottom here, in my beaker, and it's 1 molar concentration, so 1 mole per dm cubed. And I've put a piece of copper metal into it. So this copper metal is going to act as an electrode. Now, at the moment, there will be an equilibrium set up between the copper ions that are in the solution and the copper ions that are in this piece of metal. So I've just done a diagram of that I want to use to help illustrate what's going on. So this is the equilibrium reaction, the equilibrium mixture that I've got, copper ions that are in the solution and copper metal that's in my electrode. Now, if those copper ions in the solution were able to gain 2 electrons, they would also become copper metal, and my equilibrium would move over to the right. If the copper that's in the electrode here, that's in the metal, were able to shed 2 electrons and move over to the left here, the 2 electrons would be released and we would have more copper ions in the solution. At the moment that can't happen because there's no source of electrons to come into this mixture, and there's nowhere for electrons to go should any ions drop out of my copper metal. But if I were to pair this up with another half cell, then I would have a different situation. So I've got another one here set up, another diagram, and this is for a magnesium half cell. So you can imagine what that would look like, and I've got one that I've made. This has got 1 mole per dm cubed magnesium sulfate in the bottom here, and I've got a piece of magnesium stuck into my beaker here. So I've got a magnesium electrode here and a copper electrode here. And you can see I've got exactly the same kind of equilibrium being set up here between the magnesium ions that are in the solution and the magnesium metal that's part of my electrode. And again, nothing can happen here either because there is nowhere for the electrons to go. But we might like to hazard a bit of a guess about what would happen if I were to connect these two together. So if I could put a wire between these 2 pieces of metal, between my 2 electrodes, we might like to have a think about what could happen. Well, we know that copper is not a very reactive metal. It's not very good at doing this backwards reaction. It's not very good at losing electrons and becoming Cu2+ ions. On the other hand, we know that magnesium is a reactive metal. That means it's very good at doing this backwards reaction. So it wants to, if you like, lose electrons and wants to form these Mg2+ ions. So if I were able to connect these 2 together, I might suspect that I've now facilitated an overall reaction between the 2, where the magnesium that's in the electrode is able to move out and into the solution. The electrons from that electrode could then travel along my wire to my copper, and as those electrons built up in this piece of copper metal, that would attract the copper ions in the solution onto it and effectively build up the size of my copper electrode here. It would get thicker and bigger. There's only one thing stopping this process, and that is the electroneutrality of the solutions here. Obviously, if I've got magnesium ions moving into this solution, but I don't have enough sulfate ions in there to balance them, then my solution is going to gradually get more and more positively charged, and that will inhibit more ions moving out of the magnesium into the solution. And the same process is going to happen on this side. If I have copper ions migrating onto the electrode and depositing on there, I'm going to end up with sulfate ions being left over in the solution here, so lots of 2- charges and not enough 2+ to balance them. And so the solution would gradually become more negatively charged, and that would inhibit the process of these copper ions migrating onto the electrode. So I need to have an additional piece of equipment to help complete the circuit, and that's going to be something called a salt bridge. I'm going to draw this over the diagram here. And now this can be either, well, I'll show you, it can be either a glass U-tube that I filled with something where the ions can migrate very, very easily. And I've got one here that's got sodium chloride solution in it. So if I were to invert this between my 2 beakers, then I would be able to have the appropriate ions flowing into either side in order to maintain the electroneutrality of those 2 solutions.